How's everybody doing here? Yeah, I would like to ask a question. We were talking about MOOCs and online education and the future of the university and the transportation system, and I'll talk about all of that, I assure you. But how many people here have taught or actually taken a MOOC? Who doesn't know what a MOOC is? Oh, it's entered the popular mainstream. So if you read the popular press, and if you even read the recent NSF proposal, MOOCs are thought to be dead in some ways. There's always what's called a Gartner hype curve in industry, and there's always a trough of disillusionment in that. And what I want to talk about today is really, I think, not disruption, but rebundling lifelong learning and rebundling professional learning here. So I want to start with perhaps what is the economic challenge. And then I want to talk about program design in two terms. One is as a product design challenge, and the other came out of some work we did with the Santa Fe Institute, this is really a multi-sided network. This is really a complexity science challenge, and we'll talk about that as well. And then, since we have bits to look at and data to look at, I want to talk about the impact of learning design, the ability to put an X-ray machine on learning behaviors in the classroom, and finally, learning curves and personalization. And if the agendas here have converged, it was partly by accident and partly not, so I thank the organizers for this. So let me start with what's the economic challenge. Anybody know who this photograph was taken by? This is a Louis W. Hine photograph. Louis W. Hine back in the Depression when Roosevelt decided to put people back to work. He didn't just put feet on the street, but he also hired photographers and artists and sociologists to document the human condition. And this is one of the great photographers, who's one of my favorite photographers, Louis W. Hine. And so you could see what that first phase was. Here's what I want to say. We're here, we're all higher education. And I've been looking at this problem, this challenge of finding people for skills for some time now. And here's what's happening. The needle isn't moving. So we talk proudly of new programs in data science, and yet 48% of executives say it's hard to find and retain data and analytics talent. We say that there are measurable gaps in employee skills, all these sources. Perhaps the real challenge is the struggling with the skills shortages that are coming up over and over again. And so, and then we look particularly in our country here, and we look at how many women actually stay in the engineering field when they enter the profession, and then the number of data science roles or part roles that are going to be in our economy here are going to be 2 million, or probably 20 million professionals, engineers, 20 to 40 million out there right now. So a not small number need to focus on finding the meaningful patterns in data, as we're all doing here today, in order to help business and society. And so if you know what MOOC completion rates are, I just want to show what these look like in a way. So I'll tell you the end of the story first. So like executive ed programs, which are money makers for schools, instructor-led training is not always, shall we say, backed by the most rigorous of examinations at the end. And yet it's a big moneymaker for many institutions. It sustains many institutions. And so you get very high completion rates, but you're not measuring grades or mastery at any level. We have online tutorials at Microsoft. We're seeing 4% completion rates on those. In case you think that MOOCs are dead, Microsoft put its MOOCs on edX. For those of you who know me, I was the founding VP of engineering at edX, but this decision was made before I was there, and we're seeing 5 to 7% completion rates. Now you say, oh, that's high, maybe it's 2 to 3% for others, but consider the following. 1 million users are coming through over 100 courses. That's a pretty big number. And so what I'm going to describe today is the development of the Microsoft Professional Program in Data Science. Our first cohort saw across options for 14 courses, a 29% completion rate. That was our first cohort. We recruited that cohort. We gave them absolutely no incentives. We called it privately the Speedy Jane track, the regular Joe track. So this cohort that I can talk about today was really a cohort very limited. We tried to keep it to under 1,000 students, but today, in a little over a year, we have over 2,000 grads in 1 year. And I don't know of other institutions that report their numbers, but we're pretty committed to doing this. So let me start right here with what is the challenge, what is the design challenge, and what's the systems challenge in building out these programs, or building out this program. How many here, well, let me tell you what conjoint analysis really is, if you haven't done it. If you've ever bought a bundle from your cable company and had to decide which channels and internet provider, or if you had bought that from your phone company and it's a bundle, they've probably used this statistical technique called conjoint analysis. And it's really a market research technique. And so what you really want to do in this market research technique is try to understand what a bundle might look like and what are the features that are really important. And this is very well known as a market research technique. It's used all across the board. So how's it done? You define all of the product attributes you want to test. You generate an experimental design. That's all plugged into a survey which has discrete choice. You target your audience, and then what you're doing on the features is you're using some Bayesian modeling to derive the preference coefficients, and then you use Monte Carlo simulations to test out the different offerings. And you get something that looks like this conjoint analysis metrics. And so, for example, you want to know some of the bundles. Now, I don't know how many faculty actually ask their students, what would you prefer? Let me design my course for you. Or, where should this go? Or, how is this all going to work? But if you're an industry and you're thinking about a product and you really want to have a home run and you want to change it, then you use not just the prototyping, the lean development technologies, which we all did. Believe me, we did all lean. But we also took a look at this. And so we want to know what kind of content people wanted, what were the outcomes they wanted, what did these features mean to you as a preference? Did you need to test out, for example? No. So what were and then we bundled some of these in order to take a look at what this was. It's not important that we go through what all these features are right now. And I'd encourage the universities here to really think about this as a design technique. So this is a visualization. Let me tell you, I got 50 of these diagrams, okay? So if it's hard to read, I intentionally put it up here. But it's hard to go through all of this, but in order to derive a bundle. But what you can see here are demographics. You can see STEM, non-STEM, male, female, age, how long you want to spend here, how long you've been in the workforce, all of this in order to determine one feature, number of hours. This is a visualization challenge when you have this for every single feature, and we haven't cracked it. But there were some key product findings that we found. So the first is every faculty member optimizes for course design. That's not what students want. Students wanted program design, and we actually will talk about subway maps, the transportation system as well in a little bit. But they want to have a destination, they want to have multiple on-ramps, and they want to know where they're going. And these are, the surveys we did covered students in university and lifelong learner or employed professionals. And we were particularly targeting two demographics. They were mainly millennials and people in the workforce for already 5 to 10 years. Short engagements and investment lengths all mattered. Mobile and what people are calling asynchronous, and bundling really mattered to people. They didn't, paper course was really one way to do it, but really what they wanted was a bundle. So this Georgia Tech idea is a pretty good idea. At the end, it was all about connecting graduates to employers. And yet, if you look at this challenge as, and I'll talk about this in a second, as an economic challenge to connect to employers, how do you do that today? As we heard earlier, it's all about brand. If you've gone through it, it's not about the optics into your GPA. It's not about the optics into what your projects were. It's not about the optics about how relevant your course material was to your job. It's a brand sell right now for the major jobs. And that's a real challenge. So let me, for those of you that are familiar with Boston or subway maps and transportation, here's what we came up with. And this is a little overloaded, but I'll show it to you. The blue line in Boston gets you from the airport downtown. And so the blue line is some of the basics. It's an on-ramp that brings you to what is data science. You have to know some relational, how to query relationally. You have to do some visualization. And that's the first cohort. We've reported on these numbers. And then you see the first big drop was in this course, Intro to Stats. This course was actually not taught by Microsoft. This was actually taught by a partner. All these courses were partnered. Then, so the red line brings you to Cambridge. It brings you to Kendall Square. And then apply data science. And finally, can you get to a big project? And so you had choices all along the way. And we saw in the first one, 30%, it's now down to 15%. So what is that all about? So we have this transportation network. Students can choose. They have a goal. They have these subway maps. They have multiple entry points. But why? So now I want to talk about the economics here. A professional program, and we always think about the university as 4 years or an executive program. And it's held at the university, and it's taught by the university. I want to ask you all, how many hotels does Airbnb own? 0, right? What does that tell you about the need for the university to be the exclusive partner in providing a professional program? You're all relying on brand. So this is a big challenge. This is an economic challenge. And we know that these models, and thank you again, David, for stimulating me a year ago. I think it was a year ago, November. But understand what a multi-sided network is. This is a fundamental economic principle that will transform this industry, which is it's a business model that allows producers and consumers to connect where they create and exchange value. And so the disruptor or the rebundling or the unbundling will come from a multi-sided network. In other words, I, Microsoft, have a goal. I need to produce trained workers who can use our products. I can't just train them in product. Because, first of all, I don't have all that capacity. I don't have distribution. What else don't we have? We don't have all the best learning expertise. We don't always have the best platform here. So we need to partner. And I know that some of you may be thinking, oh, Microsoft, but we're an open stack. And we're thinking about this as an open network with partners. And how do you think about this? There are various factors you think about when you look at that. But how is it easy? So I'm designing here what I would like you all to think about, which is what's the multi-sided learning network? What we care about is the data. At the end of the day, in a multi-sided network, it's all about the data. And can we attract more network participants? If you're building your own data science curriculum, what's your distribution vehicle? Who else can teach? How do you get it? How do you make it transportable? So I'm going to close. That's the economic framework in which we have started to approach this set of next generation learning. Now I want to just talk about learning design. So for those of you who might have been motivated by a particular scientist or a particular visualization, many of us, I think, are here because never underestimate the power of the visual cortex. This was, for me, I hope this reminds you of DNA. I hope this makes you think of Rosalind Franklin. Rosalind Franklin was Watson and was the X-ray chromatographer who actually visualized DNA for the first time. And posthumously, you can't be awarded a Nobel Prize. She died of ovarian cancer. But I just wanted to see, was there a visualization here that could lead to some impact? And in this visualization, let me share with you how to read it. The yellow are the yellow is some form of HTML, the green are the video, the black are the problems. And so what I hope you can see here are some identical twins. Those are, well, if I could point, I'd point, I'm sorry, but identical twins. And here are two courses in visualization. And so I couldn't figure it out, 23% and 6% pass rates in different courses, and yet high pass rates in the others. That's what the eye would tell you. But some work, and I didn't know when we were sponsoring this that we'd actually have the people that did this work, but Payan and Taylor are here. Thank you very much. Oh, there you go. Thank you very much. This was some of their work here. And so I thought Mike Ritchie at Boeing actually sponsored all this work, and we just consumed it because we collaborate. So here's how you read this. Going across, this is all the utilization. I feel like I should have you come up and explain it to Payan or something. But you have the utilization here, and a percentage of the students of the learners are all utilizing all the materials. And so both these, right, look pretty similar. As you're going down, the bulk of the people, they seem to look at this pretty sparsely as they go across the content objects. Okay, and so, wow, these are the same DNA here, and we produce this over and over, and if you were to look at a Boeing class, you'd actually see that even though these courses have the same DNA, they pretty much have the same pattern. Now, I want to look at two courses with different DNA by the course module. So visualizing data with Power BI or visualizing data with Excel, pretty important to do. I was surprised that they actually have very different, they have what to me looks like different bands here, and the different percentage of the bands. Of course, that's 50,000 students at the top in one run, and that's 12,000 students over here in one run. And this runs asynchronously every 3 months. So it seems, maybe I'm not sufficiently visual literate, but this bottom looks less sparse than this bottom. So maybe the DNA did have an impact. We'll have to look at that some more. and then we want to look at the video length. And now that's not captured in that DNA chart. But basically, there's a paper that we did early on at edX that talked about length of video and how immediately afterwards you might go and actually do an assessment. And this holds through right here, which is, sorry, nope, that's not what I wanted. Here's the x-axis, the y-axis, which is the median of the video length. So how long is that video? And then what would you think of how many people viewed that video? You want to make sure very few students look at your video, make it long. This held, so the sage on the stage, the lecturer for 45 minutes, probably not a very good result here. And we could see what's happened as you decrease the time in terms of viewing and how that goes. This should provide insight to faculty members who deliver the lectures. So we talked a little bit about the DNA of the course and what makes good courses, and these are just some of the factors. We have many more. But what are the optics into the learner behavior? Anybody here observe millennials learn? What do you know about them? I'm going to tell you something here. Let me tell you how to read this chart a little bit, okay? And so these are actually box plots. So you think about the ends, right, and you think about where they go. So what this says here is, our generation, or my generation, I should say, I actually do things pretty sequentially. If the course order is watch the video, do the assessment, watch the video, do the assessment, that's pretty good, and you can see that going up and down. When you get to the millennials, they actually have a different learning strategy, and it's shown right here in this graph. They actually attempt the problems first. Now, what does that mean for your course? That means that if your assessments are all summative assessments, if they're high stakes, those learners aren't going to do very well. And so we actually had a problem like this at Microsoft, where somebody came and said, our training partner is really complaining their learners can't get through the course. I said, oh, really? I said, oh, how old is that learner? I said, what do you mean? Aren't you worried about it? I said, no, just tell me how old the learners are that can't get through. They're all millennials. No surprise to me, I'd already informed the course instructor they need to change this policy. So we have optics into how people are learning. The data tells us. Now, I've heard anecdotally from women who code in other places that women don't move on as quickly and that women are completers. So we decided to measure learners, and we only measured successful learners and highly successful. Successful learners, we considered those people who had completed after 4 minutes and then after 5, and then highly successful 9. And so what you see here is, look at this curve. Women are completers, both cases, as opposed to the men. Now, I'm told I only have 1 minute left. So I'm going to now talk about this dream of adaptive learning. Everybody knows what the dream is. The dream is that the system's going to adjust for you and tell you what the learner knows. So we've actually created an open source adaptive engine in collaboration with Harvard. It's called Project ALOSI, Adaptive Learning Open Source Initiative. Here's the thing about the adaptive learning. Here's the penicillin in the jar. You can actually look at learning curves because our Bayesian model, the BKT, we want to know how people are learning. We have to measure that. So here's an individual. Sorry, I'll take it right here. And this here is what their probability of mastery is. Look at this person on the red line right here. We thought they knew it. They attempted a problem. They attempted another. They got it right. No, they blew it. Went down, went back up. They were guessing. we can actually have insight into individuals. We then clustered this in 3 groups so we could see what was happening. Of course, these people up here finished, the blue group. This was the K-means, this was another clustering. These guys up here, they only got so far, and then you could see them going down. Here's what's amazing about the lower group right here on this. What's amazing is some of these people really could go up, and then they stopped. They gave up. And so let me just say we can now look at this, and I'll finish up with this remark. So we split the data analysis, basic data analysis for using Excel into 3 cohorts. We ran an ABC experiment, and you can see the 3 cohorts here by group. And so pretty consistently, let me say this, look at how smooth these curves are. Can you tell which is the adaptive learning? There are 3 cohorts. The green is the cohort that the instructor taught to, and the yellow and blue. The blue, if I remember this correctly here, let me look. Yep, Group A, we optimized for mastery. That was, and Group C, which is continuity, which is another known educational strategy. And so let me say this. If you had a disease called learning, you'd want to be on a smooth trajectory to greater return, mastery, and you'd want to, in the early days, be able to stick with it. And this is just 8 weeks into this data, so it's live. My colleague Yigal Rosen is presenting this up in Vancouver early, but look at those curves. So you get greater mastery, greater persistence with adaptive learning. There are no meta-studies of this, by the way. Okay, so, and you can look at the differences in these curves right away. I'll wrap it here, but look at this. This yellow's function here, right? Early on, you get greater in the blue group. What seems to be happening here is that getting mastery or optimizing for mastery brings you to a greater point. But I don't know if this is statistically significant. We're seeing a 1 sigma difference right now between the groups, but I don't know if it'll hold. So that's all.
Questions?
Bill.
So rather than give a 45-minute video, you would have us